You know how it is. One minute, it's a bright, sunny day, perfect for a picnic, and the next, a sudden thunderstorm sends you running for cover. Weather is this constant thing in our lives. It's happening all around us every single day.
But let's really think about that. Have you ever just stopped and wondered why? Why do we even have weather? Why isn't the air just still? Why does it do all this crazy stuff? Well, that's exactly what we're going to break down. So it all starts with one single massive source of power, the one thing that's the most important driver for literally everything that happens in our atmosphere, our sun. The sun's energy is basically the fuel for all our weather. But here's the absolute key. That fuel isn't spread out evenly across the planet. And this simple imbalance is what kicks the whole weather machine into gear. This slide shows that imbalance perfectly. Think of the sun's energy like a flashlight beam, okay? At the equator, the sun's rays hit the Earth pretty much straight on, creating this focused, intense spot of heat. But at the poles, that same beam hits at a really sharp angle, spreading all that energy out and making it way weaker. This one simple difference in heating, that's the first domino to fall.
All right, so what happens next? Because that uneven heating has an immediate and pretty dramatic effect. It forces the air in our atmosphere to start moving a lot.
It's actually a beautifully simple cycle when you think about it. It's basic physics, right? You heat air up, it expands, becomes less dense, and poof, just like a hot air balloon, it rises. Well, that leaves an empty space that needs to be filled, so cooler, denser air sinks down to take its place. This constant global scale swap of rising warm air and sinking cool air, that's what we feel as wind. And all this up and down movement has another really critical effect. It creates areas of high and low air pressure. Just picture these huge columns of air. A rising column of warm, light air is going to exert less pressure on the ground below it. But a sinking column of cool, heavy air, that's going to push down a lot harder. And here's where it connects directly to the forecast you see on the news. Where that warm air is rising, you get a low pressure system, and that usually brings clouds, rain, and storms. But where cool air is sinking, you get a high pressure system, which gives us those calm, clear skies. So next time a weather forecaster says a high is moving in, you'll know exactly what they're talking about. Okay, so we've got heat and we've got air on the move. But there's a third crucial ingredient we need to add to the mix to get the weather we all know. And that ingredient is, you guessed it, water. This is the water cycle in action, and it's totally tangled up with the air movement we just talked about. As that warm, rising air carries invisible water vapor up into the atmosphere, it starts to cool down. That cooling forces the vapor to condense back into tiny liquid droplets, and that's what forms the clouds we see in the sky. When those droplets get big and heavy enough, we get precipitation. Rain, snow, the whole deal. So we have our key ingredients: heat, air, and water. But there's one last massive force that shapes how all these things interact on a global scale. And that's the fact that our planet is constantly spinning. This brings us to the Coriolis effect. Now, it sounds a little complicated, but it's really not a force in the way you might think. It's an apparent effect that happens simply because we're on a rotating planet. Imagine trying to roll a ball in a straight line across a spinning merry-go-round. It would look like it was curving, right? The exact same thing happens with air moving across our spinning Earth. And the impact of this is huge. It's the reason big storm systems like hurricanes have that signature spin. It helps organize global wind patterns into these predictable belts. Without the Coriolis effect, weather would move in a totally different way, probably in straight lines from the poles to the equator. So let's put it all together. The recipe for weather really has 4 key ingredients. First, you start with the sun's uneven heating. Second, that causes the constant movement of air, creating wind and pressure systems. Third, you add in water, cycling through the atmosphere. And finally, you stir it all up with the spin of the Earth. That's it. That is the formula for weather. And that's really the big takeaway here. Weather isn't just one thing. It's this incredibly complex and beautiful interaction. It's the result of all of Earth's major systems: the atmosphere, the oceans, the land, and even the planet's own motion, all working together all the time. It really is just a giant global machine constantly running. So the next time you feel the wind pick up, or see clouds gathering in the distance, or even just enjoy a perfectly sunny day, maybe you'll see one of these forces in action. What part of the machine will you notice next?